Welcome back to the deep dive. Today we are heading to a location that for decades really defined the absolute limit of confinement. We're going to the rock, Alcatraz. It really is the ultimate locked room mystery, isn't it? But deployed on this massive industrial scale, you've got this 12-acre slab of sandstone just sitting in the middle of a freezing, churning washing machine that is the San Francisco back, exactly. And usually when you hear the story of the infamous June 1962 escape, Frank Morris and the Anglin brothers just vanishing into the night. It's framed almost exclusively as a true crime story. It's all about the cops and robbers dynamic. Who were these guys? Did they survive, were they spotted in Brazil? 20 years later, that kind of thing. Which is a compelling narrative, sure, but we were taking a completely different approach today. We're looking at a stack of sources that treat this event not as a crime, but as a high-stakes engineering project. Because when you strip away the prison setting, what you actually have is a complex mechanical engineering challenge, and it's being performed under the most hostile conditions imaginable. Absolutely, yeah. You have extreme resource scarcity. You've got active surveillance and the physical environment that is actively trying to kill you. And our main guide for this deep dive is this fascinating analysis by Mark Robert. Now, for those who don't know, Robert is a former NASA engineer. Yeah, he worked on the Curiosity rover, right? And he didn't just read about the escape, he actually recreated it. He used modern technology, physics simulations, and just practical testing to analyze what he calls the bootleg engineering of 1962, and that's the perfect term for it. It is, and let me tell you, what he found changes the way you look at a spoon. It reframes the whole narrative from did they get lucky to just how good was their physics, So let's set the scene. June 11, 1962, Alcatraz is the end of the line. It's where the federal system sent the guys who were, too difficult for other prisons, the escape artists, the guys who had already broken out of other places. This was supposed to be the final stop. Final stop. You have the psychological pressure of that inescapable reputation. Then you have the physical reality, the frigid water, the currents, the sharks, or at least the rumor of sharks, which is just as effective psychologically. Oh, absolutely. And armed guards who were under orders to shoot on sight, no questions asked. And inside this fortress you have three, Frank Morris and the brothers John and Clarence Anglin. And looking at their profiles is so crucial because this wasn't just three random guys deciding to run for it. This was a carefully assembled team with complementary skill sets, right? You have to look at this like a startup or a black ops team. Frank Morris wasn't just a criminal. He was the project manager, the mastermind. He had an IQ tested at 130, which puts him right on the border of genius territory. Exactly. He's the architect. He sees the systems. He sees the timelines, the variables. He's the theory guy. But theory doesn't cut through reinforced concrete. It doesn't. And that is where the Anglin brothers come in. Now, they weren't book smart in the same way Morris was, but they were incredibly resourceful. They were the fabricators. They were the guys who could look at a piece of junk and see a tool. Yeah, they grew up poor. They were laborers. They worked with their hands their whole lives. It's that classic engineering dynamic. You have the visionary and then you have the makers. And they didn't just wake up one night and decide to leave. This was a year-long project, a full year, a year of R&D, essentially a year of prototyping, testing, and an execution. Oh, let's unpack this plan. It wasn't just one thing, it was this 6-part sequence that had to go perfectly. And it all started with a problem that sounds simple but is actually terrifying. How do you leave your cell? In the middle of the night, when the guards count you every hour, every single hour. This is phase 1, the deception. The escape began at 9:30 p.m., right after lights out, but they needed to buy time until the morning roll call. That is a solid 8 or 9 hours, a huge window where their beds would be empty if a guard walks past. I'd say 1100 p.m., and just shines his flashlight and sees an empty bed. The alarm goes off and the plane is completely dead. So they built decoy heads, and this is where the bootleg engineering just really shines right out of the gate. It's incredible. They didn't have clay. They didn't have plaster. They had access to almost nothing. So they created this composite material using soap. It's basically prison-grade polymer clay. They used soap as a binder and they mixed it with concrete dust they swept up from their digging and toothpaste. Think about the chemistry there for a second. I mean, the fatty acids in the soap would act as the plasticizer, right? The concrete dust is the aggregate. It gives it strength, and the toothpaste. It likely added some liability and maybe even masked the scent. And for the realism, they didn't just sculpt a lump. They used actual human hair, which John Anglin stole from the barbershop where he worked. He would sweep the floor, pocket the hair, and then bring it back to the cell. That is just the level of dedication. But here's the thing, Robert's team, they recreated these heads using the exact same material. They brought in an art director to help. Which is fair, because Clarence Anglin was actually known to be a pretty decent artist. Okay, so that's his contribution, right? And the result, what Robert described it as creepy, he did because it relies on the uncanny valley effect, but specifically under low light conditions. Exactly. In the bright light of a lab, sure, it looks like a soap doll. But in the dim, indirect light of a cell block at 2 o'clock in the morning, partially obscured by a blanket, it looks terrifyingly like a sleeping person. And Robert tested this. He had a guard in his recreation dual walkthrough. And it worked. It fooled them completely, which is the whole point. So the heads buy them the most valuable resource they could possibly have. Time. But they still have to get out of the actual cell. And this brings us to the most tedious, physically demanding part of the entire plan. All the ventilation grade, every cell had this small 6 by 9 inch air vent near the floor under the sink. It's tiny, barely big enough for your head, right? To get a human adult through there, you have to chip away all the concrete surrounding it to widen the opening, and you have to do it without power tools, without a sledgehammer, and most importantly, without making any noise. Oh, this is where the spoon comes in. The legendary spoon. They stole spoons from the cafeteria, but you can't just dig with a regular spoon, it would bend immediately. It's useless, so they had to modify them, right? They ground down the bowl of the spoon, using the abrasive concrete of the cell walls to create a little pick or a chisel. But even then, digging through decades-old salt-hardened concrete with, untempered steel is, well, it's agonizing. Robert's team tried this. They sat there scratching at a concrete wall with a modified spoon. And they realized almost immediately, you're going to be here for 10 years. Yeah, the rate of material removal was microscopic. It was just dust. It highlighted the sheer grit involved, for sure, but it also highlighted that they needed a better way. They needed something more, and this is where Frank Morris's genius kicks in again. He realized manual scratching wasn't enough. He needed a force multiplier. He needed power. He needed power, and he managed to steal a motor from a vacuum cleaner. A vacuum cleaner motor. I just love this detail. It's so audacious, it's incredible, but think about the engineering challenge here. You have a motor, you don't have a drill casing, you don't have a chuck to hold a bit. You don't have a handle, you had to build a housing, probably out of metal scraps or wood from the workshop. Then they had to attach a drill bit, which was probably just a sharpened rod to the spinning shaft and the power. Where do you plug it in? There were no outlets in the cells for power tools. There were outlets for electric shavers, but those are very low amperage. Morris had to splice into that circuit, likely bypassing fuses to run this hydro vacuum motor. It's a bootleg rotary drill, but a vacuum motor running at 10,000 RPM in a concrete echo chamber. That's going to sound like a jet engine taking off. A guard would hear that 3 blocks away. And that leads to the next layer of the plan, audio camouflage. This is straight out of a movie, but it actually happened. It did. Alcatraz had a music hour. It was from 5:30 to 7:00 p.m. Inmates play instruments so Morris coordinated with the team, while one guy drilled another guy. Usually one of the Anglins playing the accordion would play as loudly as possible. The accordion as a noise-canceling device, precisely, and think about the acoustics of it. An accordion produces this complex multi-frequency sound. It's loud, it's resonant, covers a really wide spectrum. It masks the specific high-pitched whine of the motor and the grinding of the concrete much better than, say, a guitar would have. It's the perfect cover, and it allowed them to drill a series of holes around the perimeter of the vent, so they essentially perforated the concrete like a postage stamp so they could then chip out the chunks in the middle. Much more easily, easily being a very relative term. Very relative. It still took months of this, yeah, but eventually they break through. And what's behind the wall? It's not the outside. It's a utility corridor, a service shaft that runs the length of the cell block. This was their highway, but it wasn't just a path out. It became their workshop. These two, the secret workshop. I think this is the most audacious part of the whole scheme. They weren't just sneaking out. They set up a factory inside the prison. The secret factory. They found this loft area above the cell block ceiling. Just a dark, dusty space. But how do you work in a loft right above the main cell block without the guard seeing you? Well, one of the conspirators had a maintenance job painting the ceiling. Social engineering at its finest, absolutely. He convinced the guards that the painting was creating too much dust and making a mess below on the main floor. So he asked for permission to hang blankets to catch the dust, and the guards, probably just wanting to avoid extra cleaning work, said yes they did, and behind these blankets the inmates created a hidden studio, a private workshop. They worked there for months, sneaking you at night, creating the gear they would need to survive the water. And they needed serious gear, because the San Francisco Bay on a good day is maybe 50 degrees Fahrenheit. Hypothermia sets in within 20 minutes. You cannot swim it. You need a boat. So they were building a raft and life vests, and this is where the research comes in. Frank Morris, remember, he worked in the library and he found old issues of Popular Mechanics, the internet of the 1960s, pretty much. He studied articles on raft design and life vest construction. He's learning about vulcanization, about waterproofing, about seam integrity and the material. They chose raincoats, rubberized army-issued raincoats. They acquired over 50 of them. Can we just pause on that? 50 raincoats. How do you hide 50 raincoats in a maximum security prism? That is a logistics question, but they moved them up to the loft, likely one or two at a time, hiding them inside musical instrument cases or under their own clothes. It's pure supply chain management. Wow. And then the fabrication began. They cut the coats into strips and used rubber cement to glue them together. Robert's team did this too. They got the same kind of material, accurate rubber cement. And they emphasized something terrifying about this process. Seams. The seams are everything. You know, the critical failure point. You're gluing rubber to rubber in the dark. You have to press it perfectly. If you have a single pinhole leak, you are dead. You are going into freezing rough water. A leak means the raft deflates. It acts like a wet blanket and it just drags you down. And they were doing this. The silence 15 feet away from guards patrolling with Thompson submachine guns. I mean, the pressure is just unimaginable. It's high-stakes manufacturing. And they solved the inflation problem, too. Remember the accordion, the noisemaker? It had a dual purpose. Of course it did. They modified the accordion to function as a bellows and air pump. That's brilliant. Robert tested this. It took about 37 pumps of the accordion to inflate their recreated raft. It actually worked. So you're repurposing the same tool for first psychological warfare, the noise, and then from mechanical function, the pump. It's just genius level thinking. So they have the raft, they have the life vests, they have paddles, which they made from scraps of plywood. Now they just have to get out of the building. Phase 3, the mechanics of exit. They're in the loft. They need to get to the roof and there's a vent, i.e. leading you right. But it was covered by a heavy steel grill and blocked by a steel bar. A restriction bar meant to stop exactly this kind of thing. He was a solid steel rod. They couldn't cut the bar. He was too thick, too loud. So they built a tool, a bar spreader. Okay, talk to me about this bar spreader. This is a piece of custom engineering. This is pure mechanical advantage. They took two bolts with opposite threading. So one twist left, one twist right, and they connected them with a turnbuckle in the middle. Exactly like a car jack. When you throw in the middle piece, the bolts push outward. It converts that rotational force into massive linear force, enough to silently bend steel. So they used this homemade tool to bend the restriction bar just enough to create a gap that could squeeze through. And the grill itself, let me guess, they prepared that in advance too, of course. They sawed off the real bolts holding the grill on and replaced them with fake bolts made of soap. Again with the soap painted to look like metal. Oh, on the night of the escape, they didn't need wrenches or anything. They just popped the fake bolts, pushed the grill up, and climbed out. But that night, there was a snag, problem, a loud crash. The vent cover was heavy. When they pushed it off, it hit the roof with a bang and the guards heard it. They did. The log shows a guard heard a noise, but they ignored it. It's a phenomenon called normalization of deviance in an old prison. You know, pipes bang, the wind howls. The guard likely. It's like, oh, it's the building settling. It was the one moment where luck played a huge role. So they are on the roof. The Golden Gate Bridge is to their left. The city lights are behind them. Now comes the geography problem. Getting from the roof all the way down to the water. They slid down a water pipe to get to the ground level. Then they had to cross the exercise yard. Now just imagine this scene. You're carrying a deflated rubber raft, wooden paddles and life vests, and you have to climb over 212-foot barbed wire fences without ripping the raincoat, right? One snag on the barbed wire and your boat is completely useless. And you have to do this while avoiding the searchlights that are constantly sweeping the yard. Frank Morris had picked a specific spot to launch, hadn't he? Has a blind spot on the northeast shore of the island, a place where the tower lights couldn't quite reach. So they get to the water. It's sometime between 10 p.m. and midnight. They inflate the raft with the accordion and they push off. And this is where history usually stops. The men just vanish. The FBI finds some paddles and a life vest later, but no bodies. The official story became presumed drowned. But this is where Mark Roberts' experiment gets really interesting because he challenged the assumptions about where they went right. The prevailing theory for decades was that they headed for Angel Island. It's the closest landmass just to the north of Alcatraz. Seems like the logical target. You can see it. It's land. It looks close. But Robert tested this with modern data. He did a drift test. He released 20 GPS-tracked logs into the water from their launch point at various times in the tide cycle just to map the currents. And what did the GPS say about going to Angel Island? He said Angel Island is effectively impossible. The currents in that channel are just too strong. Almost all the logs that were dropped in were swept out to the ocean or they missed land entirely. So if they tried to paddle to Angel Island, they would have been fighting millions of gallons of water moving against them. It would have been swept out the Golden Gate and lost at sea, no question. So the FBI was likely right. They drowned. Well, not necessarily because there was an exception in the data, a major one. Robert discovered a sweet spot, described the sweet spot. There is a specific, very narrow tidal window. It's about 30 minutes long. This occurs right when the tide is turning from coming into going out and, if you launch exactly during this window, the current doesn't push you to Angel Island and it doesn't sweep you out to sea. So what does it do? It acts like a conveyor belt. It pulls you west, but then it hooks around the peninsula and deposits you right at the Marin Headlands, specifically near the Horseshoe Bay area by the Golden Gate Bridge support. So if you hit that 30-minute window, the ocean effectively carries you to freedom. That's it. You don't even need to paddle that hard. The water does all the work for you. So Robert decides to test this for real. He puts his team in their Raincoat raft, the one they built using 1960s methods, and they launched during this specific window. And this is where the reality of the San Francisco Bay hits them. It is not as swimming pool. Robert describes 6-foot waves, whitecaps. The water is just churning. He called the raft a dangerous water bed, and that's a perfect description. A water bed is unstable. Now put it in freezing choppy water and remember it has no keel, it has no structure. It's just a bag of air. Robert said that battling was almost futile against the power of the waves. They were entirely at the mercy of the current, and then the equipment failure started. The scene started to go. The rubber cement bond began to fail. Under the stress of the waves and the cold, the raft began to leak and deflate. So Robert and his team ended up waist-deep in freezing water.
This is terrifying. You're in the dark if the water is freezing, hypothermia sets in within minutes in these conditions, and your boat is actively turning into a bathtub. Plus, there are predators. I mean, Robert filmed a great white shark hunting a seal right off the shore of Alcatraz during his scout for this. The danger was very, very real. But despite the leaks, despite the cold, the current its job. It did. Even though they couldn't paddle effectively, the tidal flow pulled them exactly where the GPS had predicted, toward the Golden Gate Bridge. Robert's team made it to land. They hit the bridge support. So physically it is possible, it is scientifically plausible, the bootleg engineering held up just long enough. Here's the $1 million question. Did Frank Morris know about the tides? He didn't have GPS logs. He didn't have computer modeling. This is where we have to give credit to Morris's incredible observational skills. FBI records show that Morris launched at approximately 11:40 p.m. That time aligns almost perfectly with the sweet spot. Robert Stafford. The window was between 11:30 p.m. and midnight. Morris hit it dead on. That gives me chills. How could he possibly have known that he had a year on the island?
He likely spent his time in the yard, just watching debris, driftwood, trash floating in the water. He would have tracked the tides. He would have noticed the patterns. Okay, when the tide is at this level, that log floats toward the bridge. He was collecting data. He deduced the fluid dynamics of the bay just by watching. That is the difference between a criminal and an engineer. He wasn't guessing. No, he was calculating. He identified the variables and waited for the optimal solution. So let's go to the verdict. Robert's assessment wasn't a slam dunk. Yes, they made it. No, not at all. He put the odds at less than 50%. Yeah, even with the perfect start time. Why so low? Because of all the variables you can't control. Yeah, the temperature of the water is the biggest killer. Then there's the quality of the glue. Maybe their batch of rubber cement was slightly older. There's the physical exhaustion. These men were likely malnourished compared to a modern, well-fed engineer, and just the psychological terror of being on the open ocean in pitch blackness. Absolutely. But the fact that they launched at the exact right minute suggests they gave themselves the best possible probability of success.